All right. Greetings, YouTube. Beautiful Mind here. This presentation serves as the lecture for week 6 Friday for applied statistics. A few notes to the students. Let's see. So things that we need to be aware of. Let me see. One, on Moodle, be sure that we've completed the participation and honesty quiz. Also, there's an assessment. Make sure that gets submitted. So those are 2 quizzes that are on Moodle that you want to submit as soon as possible. Those are part of your grade, and those are really important. So make sure that those are submitted. Then another major note is that on Pearson, just make sure those assignments are submitted. So I'm officially going to go ahead and let the end of chapter 6 be the last of the new material for the quarter, right? So if you felt overwhelmed, we have right outside of 2 weeks remaining in the quarter of quality time, right? Okay, so chapter 6 is going to be the last of the new material. So we have this section, and then we have section 6.4. Keep in mind, I am available. I know I have at least one student that's like really kind of going back and forth, and it's awesome. Like, I mean, not that everybody else isn't doing what they need to do, but it is nice to engage, to kind of see what people are doing. I mean, this student is going hard. Like, they are not playing around. Like, it's kind of awesome. So it's like, they're not making excuses. I mean, you can make excuses, and I get it, and it's okay. It really is okay, ultimately. No matter what happens, either way it goes, win, lose, success, or failure, it's actually okay. One, we don't really fail unless we quit. Like, we don't really fail until we quit. But then when things don't go as according to plan, then we successfully found a way that is not going to work. So we just have to keep going until we figure it out. That's it. We have to invoke the energy of until. Right? We just have to invoke the energy of until. We keep going until, right? And it's very doable, okay? So because I'm not really doing extra credit like that this quarter, my way of remedying, I can't even get that word out today. Remedying, whatever. My way of addressing that is making assignments available as early as possible with unlimited attempts. And I do intend to relax the late penalty from 20% to 10%. So what that means is that pretty much on any assignment, old quizzes, old exams, old homeworks, you get unlimited attempts. And honestly, you can still get an A on those assignments if you really wanted to, right? So the only reason any of my students this quarter would not really have an A is that essentially they didn't really want it. I mean, that's a bit of a stretch. I know it's tough. I know it's tough. But if you really, really want an A, you can honestly get it. Like, that's what I'm getting at, right? If you really want it, you could get it. You get unlimited attempts, and you can still get an A on old assignments, right? You do have to push, and you have to work hard, and that's kind of the long and short of all of that. So again, to kind of recap, be sure to submit the participation and honesty quiz via Moodle. Be sure to do the assessment on Moodle. I'll be updating the gradebook. I know it didn't update it last week. I was just kind of stepping back for a moment because but I do intend to update the gradebook, and like, if I see things are out of order, I'm gonna come looking for people. And if I can't find people, especially if things are missing, I'm gonna have to withdraw people. I had to withdraw a few people, but even if you get withdrawn, as long as you get your assignment submitted, you can actually be reinstated, right? Okay, so it really all boils down to a decision, and it boils down to what you really want. Okay, I'm really just here as a facilitator or as support. I'm just here to kind of set the stage, create the rink or arena, and I'm just here as a guide to assist you on your way. But ultimately, it boils down to each individual, and we all have to make a choice and a decision. Okay, so that's the long and short of all of that. So we'll take some time to continue chapter 6. Today, we want to continue chapter 6 and move into section 6.3, confidence intervals for population portions. Okay, so some objectives for this section are how to find a point estimate for the population proportion, how to construct and interpret confidence intervals for a population proportion, and how to determine the minimum sample size required when estimating a population proportion. So population proportion P, the probability of successes in a single trial of the binomial experiment is going to be P. So I think that's from before, all right? So this is the probability of success in a single trial for a binomial experiment is P. So the point estimate for P is going to be the population proportion of successes is given by the proportion of successes in a sample and is denoted by let me see, this is the population proportion of successes is going to be given by x over n, where x is going to be the number of successes in a sample and n is the sample size. The point estimate for the population proportion of failures, so again, let's back that up. So p hat is going to be the point estimate for the population proportion of successes is going to be given by x over n, where x is the number of successes in a sample and n is the sample size. And then the point estimate for the population proportion of failures is going to be q hat, which is going to be 1 minus p hat. The symbols p hat and it's supposed to be q hat. It's not supposed to be p and p, but the symbols p hat and q hat are read as p hat and q hat. Okay, that's a little bit of a typo. I'm not going to worry about it for right now. Okay. So in this example, point estimate for P. In a survey of 1,550 adults, U.S. adults, 1,054 said that they use the social media website Facebook. Find the point estimate for the population proportion of U.S. adults who use Facebook. Okay. Find the point estimate, right? Let's back up. So if we're finding a point estimate for the number of U.S. adults who use Facebook, right here it says that the point estimate, let's see, the point estimate for the population proportion of successes. So it's basically going to be x over n, where x is the number of successes per sample size. So we had a survey of 1,550 adults and 1,054 said yes. So the point estimate for the point estimate for the population proportion of successes is basically going to be x, which is going to be the 1,054 over the sample size of 1,550. So it's just going to be the 1,054 over the 1,550. Okay. So then a confidence interval for the population proportion P is similar to our discussion before. It's going to be the point estimate for the proportion. I'm doing that in purpose, like saying the whole thing to kind of ingrain it in. The point estimate for the population proportion of successes, all right? So the confidence interval is going to be P hat plus or minus E, the margin of error. Where the margin of error in this context, and again, all of these is really just about, most of this is really just about identifying the proper formula to use, right? Based on the context. Once you identify the context and like what's the distribution and, all of that, then, really then it's a matter of plug and chug for our discussions, right? I'm not really trying to make anything difficult or complicated, but I am trying to be as precise as possible, and but this is really a matter of identifying the context. Once you're clear about the context, like what's the distribution? Is it binomial? Is it standard normal? Can we use the standard normal to approximate the binomial, or do we have to use a t-distribution because we don't know sigma or something like that? It's just a matter of putting it in context. Once we get the proper context and we can identify the proper formula, then it just kind of flows. And this is still kind of lax because we're all at home. You can use your text. You can honestly use your notes, right, on all these assignments. So it's really just about, can you digest the information? Not that you have to commit it to your to the dome or whatever. You don't have to do it off the dome. Even when you go out into society, if you somehow find yourself in statistics, 9 times out of 10, you're going to be able to use your references, right? Your resources. So it's really just a matter of, can you digest the information? Once you get comfortable there, then eventually it'll become second nature. Okay. So the margin of error in this context is similar to before, but we're using this formula where we take the critical z value times the square root of p hat q hat over n. Okay. Where n is the sample size, p is what's the p hat? I'm still trying to, there it is. No, let's back up. I just want to say it. Point estimate, that's what I was trying to remember. It's going to be the point estimate for the population proportion of successes, right? And then Q hat is going to be the point estimate for the population proportion of failures. Okay, so the probability the confidence interval contains P is going to be C, assuming that the estimation process is repeated a large number of times. So again, the confidence interval, remember, this is where if we repeat this process for a large number of times. Remember, that was from last time, a thing that we had to be clear about. So how to construct a confidence interval for a population proportion. First, we want to identify the sample statistics n and x, where n is going to be the sample size and x is going to be the number of successes in the sample. Find the point estimate p hat, which is going to be x over n. Verify the sample distribution of p hat can be approximated by the normal, that n times p hat is greater than or equal to 5 and n times q hat is greater than or equal to 5. So that was something that we had from before, that we can estimate the binomial with the normal distribution, provided that np and nq are both greater than or equal to 5, okay? And then find the critical z values that correspond to the given level of confidence. So we have to use a table in Appendix B. You have to use Table 4 in Appendix B to find the proper z values there for whatever the confidence level that we want, okay? And then to find the margin of error E, we're going to use this formula, okay? Critical z value times the square root of p hat q hat over n. Find the left to right endpoint. So once we find the margin of error, then it's going to be basically p hat plus or minus the E. Okay. So we want to use the data in example 1 to construct a 95% confidence interval for the population. Okay, let's back up. So again, if we want to find a confidence interval, so we have our x and our n. I think it was the 1054 over the 1550, whatever it was, 1550. So we have our p hat. We need to verify that the distribution can be approximated by that the binomial can be approximated by the normal. So we need to verify np hat is greater than or equal to 5 and nq hat is greater than or equal to 5, and then use a table, find the margin of error, and then say p hat plus or minus the margin of error. Okay. So p hat was 68%, so we're going to say 1 minus p hat to get q hat. We get 32%. So again, n was 1550. We're verifying that np hat and nq hat are both greater than or equal to 5, and they are. So so we can use the normal distribution to approximate the binomial. So then using let me see. We want a 95% confidence interval. So then when we use the chart we will use table 4 in Appendix B to find the z-score that corresponds to that confidence level. So the z-score is going to end up being 1.96. So then the margin of error is going to be what you see here, right? Then once we have the margin of error, we're going to say p hat plus or minus this margin of error to get the confidence interval. So p hat plus or minus that e, we get our confidence interval. So what we're saying is that with a 95% confidence interval, the probability that the user said yeah to Facebook is within this range if the process is repeated a large number of times. Let me see if we can get that interpretation. So with a 95% confidence, we can say that the population proportion of the US adults who use Facebook is between these percentages when this process is repeated a large number of times. Okay. So I know it's a little bit like this. I'm kind of just flowing with it because it's a pre-recorded video, so that means we can pause it. You can actually like slow down the speed of the video. So if I talk too fast, you can adjust all this stuff. If I'm talking too slow, you can speed up the speed, you know. So I'm just flowing with it, and then you can adjust. Okay, let's keep it moving. So in this example, we're looking at constructing a confidence interval for P. The figure below is from a survey of 800 U.S. adults ages 18 to 29, constructing a 99% confidence interval for the population proportion of the 18 to 29-year-olds to get their news on television. Okay, so let me see. The first thing that we needed, success, right? Television was 27%. Do we need the X and the N? Let me see. So from the figure, P hat was 27%. You see it here. So Q hat is 1 minus. It says N is 800. We're confirming that NP and NQ are both greater than or equal to 5, and they are. So then we can use, so then we have to find our margin of error. We can use the normal distribution to approximate the binomial. Margin of error, the critical z value. So if we want a confidence level of 99%, so we have to use a table in the back. We find the corresponding z-score. We can find the margin of error using the formula that we had. Okay, so z-score from the chart in the back. We get our margin of error, then we say p plus or minus that margin of error to get a confidence interval. Okay. So then when the process is repeated a large number of times, we can say that the probability, so with a 99% confidence, we can say that the population proportion of this group who get their news on the television is between 23 and 31% when this process is repeated a large number of times with the same sample size and all that kind of jazz. Okay, let's look at this one. Finding a minimum sample size. Given a confidence level and a margin of error, the minimum sample size n is needed to estimate. Given a confidence level and a margin of error e, the minimum sample size n needed to estimate p is going to be given by this formula. Okay, so this is the minimum sample size in order to do this process. If n is not a whole number, then round n up to the next whole number. Okay, this formula assumes that we have an estimate for p and q. So if we have an estimate for p and q, we can do this, right? If not, use p equals 50 and p hat equals 50 and q hat equals 50. So if we're not given a p hat and a q hat, then we just use 50-50. So we're running a political campaign and wish to estimate with 95% confidence that the proportion of registered voters who will vote for your candidate Our estimate must be accurate within 3% of the true population. Find the minimum sample size. So notice here that no preliminary estimate is available. So then we just said that we have to let, because we don't have a preliminary estimate, we're gonna have to let p hat and q hat both be 50%. Let me see. We want 95% confidence, so that will come from the chart. We should get this z-score, plug it into the formula to get the margin of error, and then it should be p hat plus or minus and confidence. Oh, we want the sample size, right? So then once we have the critical z-score and the margin of error, we can find the minimum sample size needed. And since we get to 67.11, we would round up to 68. Let me see how many, we didn't say anything. So we would need 1068, at least 1068 voters. Okay, in order to do this. Let's look at another one. We're running a political campaign and wish to estimate with a 95% confidence the proportion of registered voters who will vote for our candidate. Our estimate must be accurate within 3% of the true population. Find the minimum sample size is needed. Now in this one, a preliminary estimate gives p hat to be 31%. So if p hat is 31%, that means that q hat is going to be what? 69%. Okay. If we want a 95% confidence, we can get the z-score from the chart in the back. We can calculate the margin of error. Okay, so then this was with that preliminary estimate, we would need about 914 voters. The minimum sample size should be at least 914 voters. We need a larger sample size if no preliminary estimate is available. Okay. So that was an adventure. I know that's a little fast. You have to do the best you can. We only have one more section of new material that I'd like to talk about. And then, just do your best to keep making your way through the assignments on Pearson. The reason I use Pearson is because, each question comes with an explanation attached to every question, right? So honestly, if you really want to know, you just click on the question help and there's an explanation right there. And if the explanation doesn't make sense, then I would hit up the tutor, maybe try to connect with your classmates. I don't know if y'all have a group meeting going or not, but I would definitely try to connect with tutors, and they can walk through with you, connect with your classmates, and you can reach out to me. Also in Pearson, there's the whole Ask My Instructor link. So you click on that button, and I definitely have at least one student that's making use of it, and that's what's encouraged. Most days I'm just sitting. I'm just sitting gaming and just kind of monitoring my emails, and then when some students take advantage of the Ask My Instructor, I'll do my best to respond as clearly and as quickly as I can. Also, I'm also available to go live sessions via Zoom. I think the tutors are available for live sessions. So you have support. It's 2 weeks remaining approximately. You know, we didn't come this far to just come this far. If we came this far, we need to go full throttle, right? And you can do it. It's very, very doable. Okay. So I can't think of anything else. To recap, be sure that we've submitted our participation and honesty quiz via Moodle. Also, there's an assessment. We get 1 attempt. It's timed. It is for a quiz grade. You want to do that on Moodle. Be sure that we're submitting our assignments via Pearson in a prompt manner, and just be on the lookout. So, you know, I think all the assignments for the remainder of the quarter are loaded into Pearson shy of the final exam, and I'll probably load the final exam early too because I just went through all the work on it. Okay. On that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.